You know, in our totally automated world, machines have to see. But it's not always with some super complex camera system. A lot of the time, it's with something way simpler, an invisible beam of light. Today, we're going to pull back the curtain on the brilliant little technology that acts as the eyes for our modern world.
So here's the game plan. We'll kick things off by asking how machines see in the first place. Then we'll break down the simple physics of light they use. After that, we're going to explore all the different types of sensors, see how they're set up, check out their huge impact across industries, and finally, take a peek into the future.
All right, Section 1, the invisible eyes. We're starting with the big mystery of how automated systems even know what's going on around them. So, let's just dive right in with that big question. Think about a factory conveyor belt sorting packages at lightning speed, or even just the automatic lights in your office. How do these systems actually see? How do they know something's there, or that it's gone?
Well, it's not always about fancy cameras or complex AI. Believe it or not, it often comes down to a really clever use of a simple beam of light.
And here it is. This little guy is the photoelectric sensor. It's one of the true unsung heroes of the modern world, acting as a simple but incredibly reliable eye for thousands upon thousands of automated processes.
Okay, so how in the world does this little box actually see anything? Well, the principle behind it is actually incredibly elegant.
At its absolute core, a photoelectronic sensor does one thing, and it does it really, really well. It uses a controlled beam of light to check if something is in its path. It's basically a digital tripwire made of photons.
The whole concept is surprisingly simple. The sensor has two main parts: an emitter that sends out a beam of light, kind of like a tiny flashlight, and a receiver that's looking for that exact beam. When an object passes through, it just breaks that connection, and the receiver immediately reports the change. That's it.
But, of course, not every job is the same, so it's not a one-size-fits-all kind of deal. The sensor's design has to change based on the specific task at hand.
Just think about lighting, for example. In a hallway, a simple on-off sensor is totally fine. When there's enough daylight, the lights just click off completely. But in an office, you can't have the lights suddenly shutting off while you're working. That's where a daylight harvesting sensor comes in. It gradually dims the artificial lights as the sun gets brighter, saving energy without ever distracting you. See? Two different needs, two completely different sensor logics.
And this variety is what makes them so powerful. Some sensors are set to detect objects only at a very specific distance. Others use something called background suppression to flat out ignore anything beyond a certain point. You've even got retroreflective sensors that look for a beam bouncing off a special reflector, and some that can even detect specific colors or contrasts.
The hardware itself totally reflects these different jobs. Just look at these two industrial models. One uses a visible red light, which is great for really precise short-range tasks. The other one uses invisible infrared light, so it can see things much, much further away. It's all about choosing the right tool for the job.
So we've got the right sensor. Now we've got to wire it up and tell it what to look for. This is where we get into the real nuts and bolts of it.
So, inside, the sensor is basically acting like a simple switch. The wiring comes in two main flavors, NPN and PNP. All you really need to know is that they connect that switch in slightly different ways. Picking the right one just depends on the system you're plugging into.
Now this is super interesting. It's not just about the sensor. The object you're trying to detect has a huge impact on performance. For example, a sensor that's set to detect something at 50 millimeters might see a piece of reflective white paper perfectly. But a dark, light-absorbing piece of black paper, the effective range can drop quite a bit. These are the kinds of details engineers have to absolutely master to build a reliable system.
And, you know, configuring the sensor isn't as complicated as you might think. On a lot of models, setting the light level threshold, what they call the set point, is done with a simple push-button sequence. You press it a few times to get into a menu, an LED blinks back the current value, and you push the button again to enter the new one. It's actually surprisingly user-friendly.
But getting the setup right is everything. This quote from an installation manual highlights a classic mistake. If the sensor can see the very light that it's controlling, it can get really confused. It turns the light on, sees that it's bright, and then immediately turns the light off again, creating this endless, annoying on-off loop all night long. Placement is absolutely key.
So we know how they work and how to set them up. But where do we actually find these things out in the wild? Well, the answer is pretty much everywhere.
They are the invisible workhorses of modern industry. I mean, think about the journey of a single online order. A sensor in an automated warehouse helps a robot pick your item.
Then more sensors guide it along miles of conveyor belts, making sure it gets sorted correctly. Another one checks that the shipping label is on the package perfectly before it goes out the door. They are constantly checking, counting, and sorting with unbelievable speed and reliability.
And these things are built to survive in some seriously tough conditions. To be used in a dusty, wet factory, a sensor has to be sealed up tight. A lot of industrial models have what's called an IP67 rating, which means they are completely dustproof and can even be submerged in water for a bit without failing.
So where does this simple yet incredibly powerful technology go from here? When you really step back and think about it, it's pretty amazing. The entire world of high-speed automation, from sorting our packages to assembling our phones, relies on this beautifully simple principle: sending out a beam of light and just waiting to see if it comes back. It is truly a foundational piece of technology.
And this tech isn't standing still. Sensors are getting smaller, they're getting smarter, and they're getting faster all the time. So as we move towards smart homes, autonomous cars, and even more advanced manufacturing, the real question is, where will these invisible eyes pop up next? Thanks for tuning into this explainer.
Thanks for watching, and please like, share and subscribe for such more content and appreciation. Make sure to comment your questions.